Welcome back. This is module 8 in our programming basics playlist. So far we have focused entirely on making code that actually works, the logic, the syntax, the structure. But in this video we are covering something just as important and honestly something a lot of beginners skip entirely. Writing code that's actually good. Not just code that runs, but code that's clean, readable and easy for anyone. So we will start with what actually makes code good in the first place, then walk through readability, naming, comments and formatting, the everyday habits that make the biggest difference. After that we will cover modularity, reusability, avoiding duplication and finish with an introduction to defensive programming. Let's start with the big question, what actually makes code good? Good code isn't just code that runs. It's code that's correct, clear and easy for other people including future you to read, understand and change. As you can see in this diagram, good code generally comes down to four qualities. It's correct, it's readable, it's maintainable and it's efficient. Working code that nobody can understand later is still a problem. Code is read far more than often than it's written. You will write a line of code once, but you or someone else might read it dozens of times afterwards. Then first of those qualities, readability. Readability means how easily another person can understand what your code does just by reading it. Take a look at this comparison. On the left, hard to read, cramped together, no spacing, unclear variable names. On the right, easy to read, properly spaced, clear structure, and a variable name is positive. That actually tells you what it represents. So what you need to remember here is that readable code takes a little longer to write, but it saves far more time later for you and everyone else who reads it afterward. And one of the single highest impact habits you can build is giving meaningful names. A meaningful name clearly describes what a variable, function or constant actually represents without needing extra explanation. So in the comparison table, X becomes total price, D becomes days remaining, function becomes calculate tax, flag becomes is logged in. Every single one of these tells you immediately what it holds or does just by reading the name. A good name basically documents itself. If you find yourself reading a command just to explain what a variable holds, that's often a sign you should rename it instead. Let's talk about comments and documentation. Comments are notes written directly in the code to explain why something is done, not just what the code does. The unhelpful comment just says add 1 to x here, which is obvious just from reading the code itself. It adds nothing. The helpful comment explains the reasoning, account for the free trial day, telling you why this particular line exists. Good comments explain reasoning, not just restate the obvious, and documentation extends the same idea to whole functions or programs, describing their purpose for anyone using them, even without reading every line of code. Then code formatting. Code formatting is the consistent use of indentation, spacing and layout, making code structure visible at a glance. So on the left, poor formatting, everything crammed against the left edge, no indentation, showing which lines belong to the if or the else. On the right, consistent formatting, indentation clearly shows exactly what belongs where. So consistent indentation instantly shows which lines belongs together, long before you even read the words. Your eyes pick up the structure before your brain even processes the logic. Then let's move into some bigger picture practices now, starting with modularity. From a code quality perspective, modularity means keeping each function or module focused on one clear responsibility, making the whole program easier to maintain. So on the left, we have process everything, a single function trying to do it all. On the right, the same responsibility is split into three focused functions: validate input, calculate total, and display result. A single giant function doing everything is hard to test, hard to read, and hard to fix. Breaking it into small, focused pieces, each with one job, makes every part easier to maintain on its own. So building on that, let's talk about reusability from a code quality angle. From a code quality perspective, reusability means writing code in a way that lets it to be used again in other parts of the same program or even in future projects without rewriting it. Well written general purpose functions are far more valuable than one off code written for a single specific case. And reusable code reduces the total amount of code you need to write, test, and maintain over time. So, you should ask yourself the question, could this piece of code be useful somewhere else with only small changes? If the answer is yes, it's worth writing it in a more general, reusable way from the start rather than hard coding it for just one situation. Then now we will talk about a very specific, very common problem, code duplication. Code duplication means the same logic is repeated in multiple places, and it's one of the most common sources of bugs. Here on the left, duplicated, the same tax calculation 0.18 written out 3 separate times. On the right, we have pulled the logic into a single function, tax, and simply call it wherever we need it. This is often called the dry principle. Don't repeat yourself. And here's exactly why it matters. If that tax rate ever changes, you now only need to fix it in one single place instead of hunting down every single copy scattered throughout your code. Now a concept that ties directly back to our video in errors and debugging, defensive program. Defensive programming means anticipating things that could go wrong, like bad input, and handling them safely before they cause an error. Here's an example that should look familiar. Remember the division by zero runtime error from module 7. Here we have written a function called safe divide, which checks if b equals 0 first. If it does, we output a clear error message instead of crashing. Otherwise, we safely return a divided by b. Always ask yourself what's the worst input someone could give this code, and then handle it gracefully before it ever becomes a problem. So let's recap everything we covered in this module. Good code is correct, readable, maintainable, and efficient, not just code that happens to run. Meaningful names, helpful comments, and consistent formatting all make code easier to understand at a glance. Modularity and reusability keep code organized. Avoiding duplication follows the dry principle. And defensive programming anticipates problems before they ever become bugs. So that wraps up our module 8. These habits might feel like small details right now, but they genuinely separate code that's a joy to work with from code that becomes a nightmare to maintain. If any of these practices change how you think about writing code, drop a like and I will see you in the next video. Thank you.